Okay, now we're into chapter 11, fluids. This is kind of the fun. Now we're starting to get fun. So, what is a fluid? A fluid is anything that flows. That's kind of crazy, but uh, what would that be? Liquids, water, uh, water, things with water in them, and gases. Because gases flow too. So air, hydrogen, helium, carbon dioxide. So those are fluids. So we can describe both of them together. So really everything we've done up until now has been solids. So when we talk about fluids, we don't talk about mass so much as we talk about mass density. Now you've probably talked about density a little bit. This is the mass divided by the volume. So this is mass density. So it has a symbol rho. This is the Greek letter R. So densities of common materials. So the density of aluminum is around 2,700 kilograms per cubic meter. Because it's in kilograms per cubic meter, the number is very large. Chemistry uses grams per cubic meter, so that's why their numbers are really small. And physicists like big numbers. So steel, on the other hand, which is iron with a little bit of carbon in it, is 7860 kilograms per cubic meter. But our one that we define everything by, the one I use, is water, which is defined as 1,000 kilograms per cubic meter. All right. So water has a density of 1,000 kilograms per cubic meter. It's one of those water at 20 degrees C kind of thing. All right. So let's play with this a little bit. How much blood do you have? Well, ooh, this should be in red. Where's my red? Oh, there it is. So what is blood? How much blood do you have as a fraction of weight? Gross. All right. So what do we need? We need the weight of the blood divided by the weight of a person. Well, now we know how much blood is in a person. Well, I know that a 690 Newton person has about, 690 Newton man has about 5.2 times 10 to the minus 3 cubic meters of blood in them. Well, because you just drain it out. Well, that's kind of gross. All right, I think I'm getting sick. So the weight of the blood is going to be the mass of the blood times G divided by the weight of the person, which in this case is 690 newtons. I know what G is. I need to find out what the mass of the blood is. Well, the density of blood is 1,060 kilograms per cubic meters of blood. Oh, cubic meter of blood. Well, it's not 1,000. Notice it's mostly water, but there's some other stuff in it. Red blood cells, white blood cells, antibodies, and other gross things you learn in your biology class. So density is mass over volume. So the mass is going to be rho times my volume. Notice this is a V. We've had a couple other V's. We have lowercase v for velocity. Don't make it look like this. This is a capital V. So capital V for volume. Anyway, so now let's go back. So I've got I need to find out what the mass of the blood is. So my mass of my blood is going to be my density of the blood times the volume of the blood times G divided by 690 newtons. So the density of my blood is 1060 times the volume of my blood, which is 5.2 times 10 to the minus 1060 kilograms per cubic meter. 5.2 times 10 to the minus third cubic meters, cubic meters times G, which is 10, divided by 690 newtons. When you multiply all of this out, you end up with 7.8%. You are 7.8% blood. You.